Okay, so now we're going to continue on with volumes, but not necessarily by disk. So let's suppose we have y equals x squared, x equals 0, x equals 2, and we'll revolve it about the x-axis. So when x is 0, y is 0. When x is 2, y is 4. And we know this is the shape of x squared. This is x equals 0. This is x equals 2. And we also need in there y equals 0. We'll just throw that in there right there. And it's about the x-axis. Okay, well, this is still volume by disk. So volume by disk would be equal to pi times the def integral from 0 to 2. How long is this? That's the radius of the disk. So that's x squared minus 0, top minus bottom, close it, square it, dx. And that would clean up to be x to the 4th dx. And then that would be x to the 5th over 5 from 0 to 2 times pi. And there's our answer. So what if we were to revolve it now, not about the x-axis, but about the line y equals negative 1. Y equals negative 1 is down here. And now I'm going to revolve it about this line. Well, when I extend the rectangle perpendicular right up against the axis of rotation, there is a clear piece. And as I showed you in the video, the result is not a disk, but a washer. Because if I reflect this like this, well, I'd have to reflect it about the axis of rotation. I have a clear piece now. So there's a hole in the middle. And that's not of a solid piece, it's a disk with a hole in it, which we call as a washer. So the volume by washer is pi times the def integral from 0 to 2 of v big squared minus v clear squared. And what do I mean by v big minus v clear squared? V big is the radius of the big piece, the whole rectangle. This is the big piece. So right here, this would be the big piece. And how long is that? Top minus bottom. So it'd be pi times the def integral from 0 to 2. The big piece is x squared minus a negative 1. Close it, square it. Minus the clear piece right here. This is the clear piece. And how long is the clear piece? Top minus the bottom, close it, square it. The big errors here is that people don't subtract and they don't square the pieces. So this would become x squared plus 1 squared minus 1 squared. And yes, we do have to square that. That would become x to the 4th, multiply, double it, 2x squared plus 1 minus 1. And then when we combine like terms, these would drop out. So I'd be left with from 0 to 2 times pi of dx. And that antiderivative would be then pi times x to the 5th over 5 plus 2/3 x cubed. And that's gone from 0 to 2. And the rest is just simple arithmetic. But volume by washer is the big radius, the length of the whole rectangle, minus the length of the clear piece, because we have to subtract out that volume. So it's like we take the volume of the outer radius minus the volume of the inner radius. That's the volume that we remove. It's with the big hole in it right here. So that's what we need to remove, is this part right here. Okay, volume by washer. Let's do another one. suppose we have here y equals 4x squared and y equals 4x. And we're going to do this about the x-axis. So we need the area again. So set them equal to each other. I'll take over the 4x, factor out of 4x, and here I go. And I get x is 0 and x is 1. Sketch it. When x is 0, y is 0. And when x is 1, y is 4. This is the line y equals 4x. And we know that y equals 4x squared would be this piece right here. And if you're in question which one's on top, which one's on the bottom, pick an x in between and graph. This is the area. This gets the rectangle. And now it's about the x-axis. So you have to extend that rectangle so it's right up against the axis of rotation. When it's perpendicular and you have a clear piece, it's volume by washer, not by disk. So volume by washer equals pi times the definite integral from 0 to 1. It's v big squared minus v clear squared. The big piece is the length of the whole rectangle. So the length is top minus bottom. The top is 4x. The bottom is 0 squared. Minus the clear piece, which is this piece right here. The length of the clear piece. When that rectangle is vertical, again, it's top minus bottom. So it's going to be 4x squared minus 0 quantity squared. And this just becomes 16x squared minus 16x to the fourth. That's what that all becomes. And the antiderivative would become 16x cubed over 3 minus 16x to the fifth over 5 from 0 to 1 times pi. Now let's extend that. Let's change a little bit. How would it become if we're about the line y equals negative 2? What would change? Well, the area is not changing. But what you have to do is extend the rectangle so it's right up against the axis of rotation when it's perpendicular. So again, because it's a clear piece, it's volume by washer. So it's going to be pi times the definite integral from 0 to 1. That hasn't changed. The big piece is now this. This is the big piece. So it's top minus bottom, so it's 4x minus a negative 2, because this is y equals negative 2 down here. So how long is that outer radius of that washer? It is top minus bottom. This is 4x, and this is negative 2. So it's going to be 4x minus a negative 2, close it, square it, minus the clear piece, which is this piece right here. Top minus bottom. So that's 4x squared minus a negative 2. Close it, square it. And this would have to go as, 4x plus 2, close it, square it, minus 4x squared plus 2, close it, square it. And to handle this, we would square that and get 16x squared, multiply, double it, that'd be 16x plus 4. Minus, square that, 16x to the fourth, multiply, double it, that's 8x squared, double 16x squared plus 4. And then run the minus sign through that and then collect like terms and go from there. What if I were to have it about the line y equals 4? Well, that's up here now. This is y equals 4 right here. Because when x is 1, y is 4, so it's up there. So now I'm going to extend the rectangle right up against the axis of rotation. So once again, it is volume by washer, which is pi times the definite integral from 0 to 1. This is the outer radius right here. Top minus bottom. It's the length of the whole rectangle, including the clear piece and the shaded piece. So this is 4, and this is 4x squared. So it's going to be 4 minus 4x squared squared minus the clear piece, which is right here. 4 minus 4x, close it, square it. Because this piece is 4x, so the clear piece is here, and the shaded, the whole piece is here. This is the whole piece. This is the big piece. This is the clear piece. And the clear would be then 4 minus 4x, the quantity squared. Okay, and then just one more example that's a different picture. Suppose we have y equals x squared plus 4, y equals 2, x equals 1, and x equals 3. So here, if you try to set these equal, there is no intersection because you get x squared equals negative 2 by taking over the 4. So there's no real solution there. So there's no intersection there. So if you graph this, when x is 1, you get 5. And when x is 3, you get 13. You know, this is 1, and this is going to be x squared plus 4. And then this is y equals 2, say, right here. And we're going to go from x equals 1 to x equals 3. So there's my region. So then I'm going to draw this right here. Here's my rectangle. This is the line x equals 1. This is the line x equals 3. And it's bounded by those equations. We're going to revolve it about the x-axis. About the x-axis. So I extend it so that it is perpendicular right up against the axis of rotation. So then now this would become volume by washer because it's a clear piece. It'd be pi times the definite integral from 1 to 3. The big piece is the length of the whole rectangle. That's the big piece. It's top minus bottom. So it's x squared plus 4 minus 0 squared. This is 0 down here, the x-axis. And the clear piece is this. This is the clear piece right here. The gap to the axis of rotation. So this is when y is 1, so it's going to be 1 minus 0, the quantity squared. Okay. I had this as y equals 2. I didn't realize that. So then this still the big piece is x squared plus 4 minus 0, but the clear piece, I didn't realize I had that as 2. That's 2 minus 0. 2 minus 0, I thought it was a 1. So I forgot that up here, y was equal to 2. So then I'd square that. X squared plus 4 squared would be x to the 4th plus 8x squared plus 16 minus 4. That cleans up to be x to the 4th plus 8x squared plus 12. Close it. And then you still have to take the antiderivative from 1 to 3, which, you know, is x to the 5th plus 8x to the 3rd over 3 plus 12x from 1 to 3 times pi. And again, volume by washer has to occur when it is perpendicular to the axis of rotation. So both volumes, volume by disk and volume by washer, occur when the rectangle is perpendicular to the axis of rotation. But in volume by disk, there is no clear piece. In volume by washer, there's a clear piece. And that's where it's v big squared, I call it, minus v clear squared. The volume of the outer radius minus the volume of the inner radius squared. One quick one again, if we have y equals root x, x equals 0, y equals 0, and x equals 4. This looks like real quickly like this. This is x equals 0, this is x equals 4, and this is y equals 0. There it is. That's the area. So the area would be from 0 to 4 of root x, top minus bottom, dx. If I were to revolve that about the x-axis, it's volume by disk, which would be pi from 0 to 4 of the radius squared, which is the length of the rectangle, squared dx. This is the length of the radius, just the length of the rectangle's top minus bottom. If I were to revolve it about the line y equals -4, now when I extend it up against the axis of rotation, that's volume by washer, which is pi times the definite integral from 0 to 4 of the big piece, which is right here. That would be root x minus a -4, close it, square it, minus the clear piece, which is 0, minus a -4, close it, square it, dx. And then I get here root x plus 4, close it, square it. That becomes plus 4, squared is what? 16. Square that, and I get x, multiply double this, 8 root x, plus 16 minus 16. They would drop out, and still I have to take that antiderivative yet, but I'm assuming that would be very easy. That'd be x squared over 2 plus 8 times 2/3 x to the 3/2, going from 0 to 4 times pi. Okay, so again, volume by washer is the length of the big radius, which would be root x minus the -4 squared minus the clear piece right here. And that would be volume by washer. We didn't have an example yet where we did it with the y. If you had it where it had to be perpendicular to the y-axis, then don't forget it would have to be either volume by disk or volume by washer. If there was a clear piece, it's washer. If it's no clear piece, it's volume by disk. So if it's perpendicular to the y-axis, then this has to be a dy, and everything else is in terms of y, and it would be right minus left in both cases.